Hi, I'm Wesley Deal and we're team Ohm Sweet Ohm.
Hi, I'm Joseph Field.
I'm Kevin Schwecke.
And I'm Atlas Tobin.
So our solution is aimed at addressing the problem of mechanics and other people who use tools on a regular basis frequently grabbing the wrong tool and having to walk all the way back to the mechanic's toolbox. And this problem was identified because it's something I deal with personally, helping my dad frequently work on bikes and just other projects around the house. Our solution consists of a delivery bot, which receives tools from both the cabinet drawer bot and the shelf bot, which are two distinct bots, one of which is situated on a stereotypical mechanic's cabinet, and the other one is situated on a shelf. And once the mechanic is finished with the tool, he will drop the tool in the subsequent drop station.
So the delivery bot's going to be a cart, has three shelves that you can put tools on, and it has a camera in the front that scans the tool to know where it needs to go, whether that be cabinet bot, shelf bot, or if it needs to go to the drop station based off of what the drop stationist says. It also has sensors at the front of it so that it can determine if it's on its way to its destination, if it's going to run into anything. If it comes within 6 inches of something, it will back up, turn, and then attempt to move forward again and keep going until it has a free path and can continue on its way. And this is the Arduino for that. You have the four motors, the 9-volt battery, the photoresistor here simulates the camera scanning a tool, and then you have the speaker that is going to emit a sound when it is reversing.
This is the cabinet drawer bot. It is situated on the side of the cabinet drawer and enables the arm to grab tools from multiple cabinets. I can talk about the hardware on the next slide. So it consists of two motors, one of which allows the bot to move up and down along an axis on the side of the cabinet, a hand motor which supports the gripping functionality, and then three servos, which correspond to three different joints on the arm, giving it functionality to grab multiple tools on different cabinet levels. And finally, it has an ultrasonic distance sensor, which ensures that the delivery bot is close by before the arm drops the tool, so it doesn't just drop it on the floor.
So this is the shelf bot. It's a small disc with four wheels. It will sit on a shelf, and that shelf can have bins of various different parts or things that the mechanic might need. And its function is to lift up those bins with its retractable forks and then lower them down to the delivery bot. And this is all the wiring for that. So it's got four wheels, two motors, one to raise and lower the forks, and another to retract and extend the forks. And then it's got a sensor, which is to detect whether or not there's any weight on the forks. So if a bin is missing, it will report that. And then that switch up in the top is to simulate within Tinkercad whether or not the delivery bot is present or if it needs to report it as missing.
So this is the drop station. This is where the human user interacts with the other robots, requesting or returning a tool. And on the next slide, we'll see how it's connected. Here, we have two buttons. One calls a tool and one returns a tool. And it has a light sensor that detects if there is a tool on the drop station. And then we also have a piezo that outputs different sounds depending on what the command was, and it allows it to communicate with the other robots using sound, whether to return a tool or to request for one.
So to simulate our robots, we have a mock garage. So we have our two drop stations, a toolbox that has an arm attached, and then we also have our shelf that has our shelf robot. So if a tool is sent to be on a drop station, the delivery bot would then go to that drop station. The drop station would put that tool onto the bot, and the bot would then go to either the toolbox or to the shelf. The arm on the toolbox would help take the tool off and put it into the toolbox. And then you have the shelf bot who has its raising and lowering of its forks that it would come down, grab the tool, bring it up into the shelf into its appropriate bin.
And this is our value added assessment. So here's a similar solution called AutoStore, which is put out by a company called Fortna. So the issue with AutoStore is that it's very large scale. It's made for warehouses and sorting facilities, and it's just wouldn't work for smaller shops or in home shops. And it's also very costly. It starts off around $1 million.
So overall, our bunch of robots is called the Garage Assistant Robots. It's the best solution for smaller scale operations and benefits single person or local businesses because it's much more affordable than Fortinet's solution, and it works really well at delivering tools for people. And below we also have our references.